Hello dear students, let us solve a numerical problem which is the combination of thermal conductivity and change of state. The question is, a layer of ice 0.15 meter thick has formed on the surface of a deep pond. If the temperature of air at the upper surface of ice is constant at -12 degrees Celsius, determine time taken to increase thickness of ice by 0.2 millimeter. Density of ice is 0.91 into 10 to power 3 kg per meter cube and thermal conductivity of ice is 0.5 calorie per second per meter per Kelvin. Now solution. To understand the question, suppose this is deep pond water in which this is ice of thickness L is equal to 0.15 meter. Upper surface of ice is in contact with air at constant temperature -12 degrees Celsius, whereas the lower temperature will be 0 degrees Celsius. Thermal conductivity of ice is 0.5 calorie per second per meter per Kelvin, which may be written as 0.5 into 4.2 joule, because 1 calorie is 4.2 joule per second per meter per Kelvin. Now this gives 2.1 joule per second becomes watt per meter per Kelvin. Density of ice is given to be 0.91 into 10 to power 3 kg per meter cube, which is 910 kg per meter cube. Density of ice is 0.91 into 10 to power 3 kg per meter cube, which will be 910 kg per meter cube. We have to calculate the time taken to form new layer of ice of thickness 0.2 millimeter, which is 0.2 into 10 to minus 3 meter. Now solution. Let A is lower surface area of ice, then this will conduct heat from lower surface to the upper surface, then rate of heat conducted by ice layer will be delta Q or dQ by dt, delta Q by delta T, which is K A theta 1 minus theta 2 upon length, which will be K is 2.1 into A 0 minus 12 upon L is 0.15. So dq by delta Q by delta T comes to be 168 A. Now this heat per unit time is lost by water here in the pond, which will condense into ice. Therefore delta Q will be equal to heat lost by water at 0 degree Celsius to freeze into ice, that is into ice, that is m ice into L ice. It will be m ice into L ice, volume into density of ice into L ice. Volume is equal to area into its thickness. Thickness is d into density into latent heat of ice. Question 2. This is equation 1. With equation 2, equation 1 gives A into D into rho ice into L ice upon delta T is equal to 168A. Now A gets cancelled and we get delta T as D into rho ice into L ice upon 168 equal to 0.2 into 10 to minus 3. Density of ice is 910 into latent heat of ice is 80 into 4200 upon 68, 168 upon 168, which gives 364 second, 364 second, which will be equal to 6 minutes and 4 seconds. Thus, in 6 minutes and 4 seconds, new ice layer of given thickness should be formed.